Hi everyone, welcome to Chapter 6. This one is entitled the Integumentary System and will focus on our largest organ, which is our skin. So we're going to have some fun and we're going to discuss the different layers that make up the skin, what type of cells you'll find over there, and then also we're going to discuss things like how the body heals, as well as the different classification of skin cancer, as well as burns. So without further ado, let's go ahead and let's get started. Now, let's take a look at an illustrated example of our skin. And as you can see right here, as we're looking at figure 6.1, what we can notice is, starting on the right-hand side, is that the skin itself has been bracketed into several layers. The top layer is going to be called the epidermis. The middle layer, which is going to be the largest one, is going to be called the dermis layer. And then the third layer, which is not really considered a technical or an official layer of the skin, but is always discussed along with the epidermis and the dermis. This is going to be called the hypodermis. The hypodermis is best known for the fact that it will have lots of subcutaneous fats, so lots of adipose tissue will be embedded with this third unofficial layer, as well as lots and lots of blood vessels, as you can see by the drawing of the arteries in red and the veins in blue with this particular layer. Go ahead and just take a few seconds and explore the picture. You're going to see that there are some markings that will indicate some of the structures, like for instance the hairs and the sweat pores, which are accessory glands that come up from the integumentary system. And you also will see that there's items that are labeled, such as some nerve fibers. Notice also how you have your blood vessels, as I mentioned before, that are marked in red and in blue. But more importantly, notice that the blood vessels are held within the dermis and the hypodermis layer. The epidermis layer, the top layer of skin, has absolutely no blood vessels. So we're going to have to discuss what kind of consequences that has for the epidermis layer. All right. So, as I mentioned to you before, whenever you hear the integumentary system, I just want you to think skin. Skin is our largest organ. I also want to mention that the integumentary system will include other accessory organs. These are going to be things like your different glands, like for instance your sebaceous oil glands, your sweat glands. They will also include extensions like hair, nails, claws, horn. Now, in our little lecture, we will concentrate mostly on the different layers and cell types that you would find within the integumentary system. However, please reference the book if you want to learn more about the different glands as well as different accessory organs. And as always, if you have a question, comment, or concern, feel free to email me at any time. So, let's go ahead and let's take a look at these layers of the skin that I've mentioned to you on our previous illustration. These are going to be from top to bottom. You're going to have your epidermis layer, your dermis layer, and your hypodermis. Now, once again, your hypodermis is not considered a technical layer of the skin, so it's not an official part of the skin, but it is always discussed in conjunction with the two official layers, which are the epidermis, the top layer, and the dermis layer, which will be the layer below the epidermis. Now, as you can see on the PowerPoint, it tells you that the epidermis layer will be mostly composed of stratified squamous epithelium, whereas the dermis layer is going to be more of a connective tissue type. This helps partially explain why the epidermis layer does not have any blood vessels, where the dermis layer does have them running through. The layers of the skin that will make up the epidermis primarily, as well as the dermis partially, they will vary depending on if you're looking at what we like to call thick skin versus thin skin. Thick skin is usually found in areas that are exposed to high levels of abrasion. So we're taking a look at the bottom of our feet, we're taking a look at the front or the palms of our hands, and that's because the thick skin will tend to have a thicker epidermis, thereby providing an extra layer of protection for our integumentary system. Thin skin is what the rest of our body is made out of. So this is going to be the skin that covers the neck, the torso region, the abdominal region, your legs. Thin skin is slightly thinner. It has one less sublayer than thick skin, and it will have lots of hair follicles, sebaceous glands, and sweat glands. This is important to highlight because, as you can see written in your PowerPoint, it says that thick skin does have sweat glands. We've all had sweaty palms, right? But it will not have hair follicles or oil glands. These you will freely find, all three of them, in your thin skin, which is the rest of the body. Alrighty, so let's start on top and work our way to the bottom. So let's start with the epidermis layer. This is going to be the superficial or the top layer of this skin. It makes sense that it's composed of stratified squamous epithelium. Stratified means that it has multiple layers, more than two. And squamous, of course, indicates the fact that the individual cells are very abstract, loose in their overall shape. And if you might recall also from chapter 5, keratinized indicates the fact that it has several layers of cells that are dead and that are filled with keratin, which is a very tough protein. This is going to come in very handy because that keratinized layer is going to allow us to give us an extra level of protection to make it harder for pathogens to burrow into our skin and get access to the deeper layers underneath the epidermis. Now, just something to highlight, I've mentioned it before, your epidermis layer, in addition to it being keratinized, stratified squamous epithelium, keep in mind that it lacks the blood vessels. It will get all its nutritional demands and get rid of its waste products from the dermis layer, which lies underneath the epidermis, and the dermis layer is going to be full of connective tissue. You do have nerve connections within the epidermis, and that is then why we can go ahead and feel things like a little ant walking on our skin, or when you feel pain when you put your hand on something hot. And that's, of course, because of the communication with the nervous system and the environment that we are surrounding ourselves with. Within the epidermis itself, we're going to take a look at the different cells, and we're also going to take a look at their sublayers, their stratums. So let's start off with the cells. In the epidermis, the top layer of the skin, you're going to come across 5 different types of cells. The first one is going to be classified as a stem cell. Now, a stem cell by definition is a cell that doesn't have a function. It is what we call undifferentiated. Only when it receives the proper signal, that stem cell will go ahead and metamorphosize, change into the particular cell that the body requires. Now, in this case, the stem cells that we find in the epidermis, these are the cells that will give rise to our keratinocytes. Keratinocytes are what we informally like to call our skin cells. So these are going to be the majority of the cells that we have that makes up our epidermis layer. And they all originally start off as stem cells. These stem cells can be found in the deepest layer, at the bottom layer of the epidermis, which we're going to be discussing in just a few seconds. But as you can see right here in the PowerPoint, it says they are located in stratum basal, which is the bottom layer of the epidermis. The keratinocytes are our second type of cells. These are our skin cells, as I was mentioning to you before. These will make up the majority of the cells, and partly what their name indicates is the fact that they're able to synthesize keratin, which is going to help us create a waterproof layer and a protective mechanism that the epidermis provides to our body. The third type of cell are called melanocytes. Melanocytes get their name because they're able to produce a pigment, a color called melanin. Now, depending on the amount of melanin that your body is able to display, it will correspond with the overall skin tone that you present. And it turns out that melanin has a very important role because it has been scientifically proven to show that it will actually shield your skin cells and all your other cells within your epidermis from the damaging effects that the sun rays can have. So melanin is a really good mechanism that your body can utilize to prevent things like skin cancer or any abnormalities from occurring due to exposure of the sun. The fourth type of cell is called a tactile cell. Tactile cells are also called Merkel cells, and that basically means that they're able to interact with your nerve fibers so that you can have, in essence, touch receptors that are associated with your fingers. For instance, if you have ever taken your fingers and run it across a tough surface and you feel the texture of it, or Braille, people who can read Braille, you know, the little dots increases that they do, for people who are visually impaired. The reason that you're able to see the elevation of the paper and indicate the shapes that are printed on it is because of the fact that within our epidermis, we have tactile cells, Merkel cells. So these are the ones that communicate with our nerve endings. And then the fifth cell to point out is going to be a white blood cell. It's called a dendritic cell. A dendritic cell is an example of a macrophage, which is a type of white blood cell. It's going to be very important in our epidermis because it basically shoves through the layers of epidermis and it seeks any type of pathogens that may have made their way through the layer. So it is an excellent defense type of cell, and as I mentioned to you before, it's going to work in conjunction with your immune system to guard your skin from any type of pathogens. All right, so let's take a look at figure 6.3, and what we're seeing here are once again all the different layers of skin, and let's go ahead and try to identify the 5 cells that we were just discussing within the epidermis itself. So let's start off by finding our stem cells. So you can see them right over here as one is indicated for you on the right hand side. The stem cells are the ones that will be actively dividing and producing new cells. Here's another one. And you can see, you can find them at the bottom layer of the epidermis. Okay, so here, we haven't discussed these just yet, but you can see these little sublayers are labeled stratums. These all collectively make up the epidermis. And as you can see right here below it, you have your dermis layer. So notice how your stem cells are right at the start, right at the basement level, stratum basalis of the epidermis. The next type of cell that we can look for is try to find your keratinocytes, your actual skin cells. Those are not going to be hard to miss because they are all the purple cells that you see. And as you can see, some of them are living, some of them are dead, and you can see they start moving from the bottom all the way towards the top of the epidermis. So all the cells that have been indicated for you in pink, cytoplasm, and purple nucleus, those are all your keratinocytes. So those are going to be the majority of cells, the cells that make up the epidermis. We also have our melanocyte that's pictured, the melanocyte. Here's the label. It's this beautiful brown cell right here, indicating the fact that it's able to synthesize that melanin pigment. And then one cell that you definitely can't miss is this really large green one. This is your dendritic cell. So that was that white blood cell that I was mentioning before. It's an example of a macrophage in that it scavenges. You can see it's kind of embedded within the keratinocyte. So it scavenges the environment looking for any type of abnormalities that might have penetrated through the skin. And then last but not least is this very cute star-shaped cell in blue. This is going to be our tactile cell, aka our Merkel cell, and as you can see, it's in close association with the nerve right here in yellow, and that is then where it gets its touch receptors and its ability to interact with the nervous system. So those are the 5 cell types that we need to know for the epidermis, and definitely be comfortable with explaining what their function are. So we have the stem cell, we have the keratinocytes, we have the melanocytes, we have our dendritic cells, and we have our tactile cells. Next, what I want to do is take a look at the stratums. Let's take a look at these different sublayers that you find within the epidermis. And it's important to discuss the stratums because we're going to have to explain why we have our keratinocytes that are nice and alive at the bottom, but as they migrate upward, why does their shape change? And why do they eventually go from living to dead? So we have to discuss all that. All right, so let's take a look at the stratums. Now there are 5 stratums or strata altogether, but it turns out that thin skin will have 4, where thick skin will have all 5. So there is a difference in how many layers the epidermis will have, depending on if we're looking at thin skin or thick skin. So I'll be definitely pointing out the layer that you can exclusively find in the thick skin when we get there. So let's go ahead and start at the bottom, the deepest layer of the epidermis. Let's take a look at what type of cells you can find, what's happening over there, and then we'll start migrating upwards until we get to the keratinocyte layer, which is, of course, is the layer where the dead keratinocytes are. All right, so looking at my PowerPoint, I can see stratum basal is the first layer that's mentioned. This is going to be my deepest layer. This one is best known for the fact that it will house all the stem cells. And the stem cells are, of course, the ones that are undifferentiated. They're the ones that continuously are able to divide and produce more keratinocytes, so skin cells. The reason why your stem cells are located at the basement layers is because that gives them the closest contact that they can to the blood vessels, because it has a high nutritional demand for the cell to continue to replicate and transform itself into keratinocytes. You will also have a few melanocytes in the stratum basal, and also some tactile cells because they're interacting with the nerves that you can find in the basement membrane of your epithelium layer. The next layer is going to be called stratum spinosum. Stratum spinosum gets its name because underneath the microscope, the keratinocytes, the skin cells, are going to have a elongated, spiky, almost spiny type of appearance. It's almost like they're being stretched apart. This is due to the fact that in the stratum spinosus, the keratinocytes start interacting with each other by forming different types of cell junctions. And they can use anchoring junctions like the desmosomes. In chapter 5, if you remember, we discussed that desmosomes are when the cells can go ahead and link together, creating little anchoring points, so it gives them a little bit of stretch. The keratinocytes can also do tight junctions. This is when they physically just attach with no other interaction, creating this little waterproof interaction. When the cells start interacting with each other, we see that they elongate, and that is then what we physically see, or their morphological change, is what we see in the stratum spinosum. So I've inserted this figure again just to kind of keep track of where we are. Looking on the left-hand side, we started with the stratum basal. So that's the bottom layer, and then we moved up to the stratum spinosum. As you can see, the stratum spinosum is a little bit of a thicker sublayer. It has more layers of keratinocytes. But more importantly, if you take a look at the morphology of the stratum basal, I'm just going to circle some skin cells, versus the morphology of the stratum spinosum, you're going to see that the keratinocytes are more elongated, more spiny, and you see these tiny little lines that they've drawn connecting the cells. Those are indicative of their cell junctions that they're forming. So the cells are interacting with each other a little bit more. Our next stratum is going to be called the stratum granulosum. Now the stratum granulosum, and don't worry, there is a text coming up on the next slide, gets its name from the fact because it's filled with little granules, little grains all over the place. So notice on my illustration how the keratinocytes now appear a lot darker on the inside of their cytoplasm, and they have these small little purple beads that are all over the place. So let's go ahead and take a look at what those bring to the table. All right, so the stratum granulosum is going to be filled with granules that have lots of keratinohyaline. This is going to allow us to bundle together the keratin, which is that tough protein that we require in order to form a waterproof layer, which is going to act as a protective layer for the skin itself. So in the stratum granulosum, we start seeing that the keratin will start to function in what it does, and it will create a waterproof layer. Now, when it creates this waterproof layer, it turns out that it cuts off any type of nutrients from migrating further up above the stratum granulosum, because we're literally sealing off the borders. And when you seal off the borders, that means that any cell that's found above the stratum granulosum, so the cells that are found in the stratum lucidium and stratum corneum, these are two layers that are above the stratum granulosum, those cells will start dying off because they no longer have access to nutrients. This then explains to us why when we look at our epidermis, we have that keratinized layer, that layer of dead cells that sits on top of it. Partly because obviously it's providing us a protective mechanism, but the cells were deceased due to the fact of that waterproof layer being formed in the stratum granulosum. All right, now I got a little bit ahead of myself and I mentioned to you the stratum lucidium and corneum in my little discussion on the granulosum. These two stratums sit on top of the granulosum, and I want to point out that the stratum lucidium is exclusively found in thick skin. So this is the stratum that you will not find in thin skin. It is exclusively found in the palms of the hands, bottom of the feet, so only in thick skin. It gets its name because it produces a clear protein called elidin. This is all done in a mechanism of packing up as much keratin as possible in our epidermis layer. So the stratum lucidium only in thick skin. The next layer will be our top layer, our surface layer. This is going to be the stratum corneum. The stratum corneum can be up to 30 layers long, or I should say thick, and it's nothing but keratinized cells. So cells that are dead and are still filled with keratin. This is a fantastic layer because this is the layer that's going to allow us to create a waterproof, to prevent any type of water loss. It's going to protect our body from any type of abrasion as well as penetration of any type of pathogens that are trying to enter our epidermis skin layer. So here's my picture again. We started off with the stratum basal, then we had the stratum spinosum, and then on our last slide we talked about the stratum granulosum that's going to form the granules that are going to start bundling together the keratin. And notice how when you go from the stratum granulosum to the stratum lucidium, which is exclusively found in thick skin, notice how the cells now no longer have any organelles. You don't see the nucleus anymore, and that's because all these keratinocytes have become deceased. They start dying off, and that's all due to the waterproof layer that's being formed in the stratum granulosum, cutting off any nutrition from moving upwards. And then our last layer, you can see right here, it's flaking off. That is the stratum corneum. All right, that is nothing but keratinized dead cells. All right, now I want to kind of go back to our keratinocytes, our skin cells, and talk a little bit more about them. And I want to pull some of the information that we have sort of discussed already, because I want to discuss them in the sense of why it's necessary for our keratinocytes to start at the bottom in the stratum basal and work their way up. And as they're working their way up over to the stratum corneum, this is going to be about a 30 to 40-day journey to go from bottom to top. I just want to reiterate the changing in their shape, their production of keratin, and eventually the fact that they will be exposed to that waterproof layer, which will allow them, or which will unfortunately cause them to go from living keratinocytes into dead keratinocytes and eventually flake off our skin. So our skin is continuously producing new skin cells to keep up with this ever-changing life history of the keratinocytes. Okay, so let's take a look at what our text brings us. So it says right here, it says keratinocytes are produced by mitosis by the stem cells in the stratum basalis. We saw that already, we got that going. And I mentioned to you before, this happens in the stratum basalis because that is where it can be the closest to nutrients as well as oxygen, as well as any type of growth demands that it might have because it has access to the blood vessels in the dermis layer below. Once the keratinocytes are formed, or I should say differentiated from the stem cells, the keratinocytes will start moving in an upward pattern, and they will eventually make it over to the stratum granulosum. The stratum spinosum. The stratum spinosum will get its name because, as I mentioned to you before, this is where it will start forming its cell junctions, and the cells will now go ahead and elongate and have more of a spiny appearance. As they start flattening out, they then encounter the stratum granulosum, where they start forming little granules, and this will all help them in packing up their keratin production. And as I mentioned to you before, this stratum granulosum layer will form a waterproof layer, which will prevent any nutrients from moving upwards. So the keratinocytes, as they migrate upwards to the stratum lucidium, if we're looking at thick skin, or the stratum corneum, which is thick skin and thin skin, these cells will then start becoming deceased. They start dying off. And we see this whole journey from the start to end takes about 30 to 40 days. In fact, skin is always flaking off. If you've ever done an exfoliator, or you go ahead and you get a pedicure, and if they take that little brush, or they used to do it back in the day with a razor blade, and they kind of go at the heels, and you see all those little flaky cells falling off, that is nothing but keratinized cells. That's why it doesn't hurt. It's just dead cells that they're flaking off. Also, if you give yourself a nice little facial, for instance, let's say you had a rough week, so you're going to put on a little bit of a mud mask, take a few deep breaths, just relax. After you go ahead and you take the mask off, you might notice that your skin is a little bit red and might have a nice little glow to it. Part of that is because you have taken off some of the dead cells, so you have exfoliated that particular region. And for those of us who are not interested in pedicures or face masks, don't worry, we still get lots of exposure to these flaky cells in the form of dust particles. So anytime you're cleaning your house and you see all that dust and you're wondering, where did this come from? Part of it are the old cells that are flaking off your skin and falling in your environment. Now, as we age, the process of producing our skin cells and its migrating pattern will slow down, and we do see that if the skin is persistently injured or stressed, it will speed up the production of the keratinocytes, and that is then what can cause calluses or corns to form. Calluses or corns are usually found on the hands or the feet in areas that have exposure to high amounts of abrasion. And this is all due to the fact that the abrasion is causing the keratinocytes to proliferate at a higher rate, causing them to start bunching together as they die off. And the thick accumulation is then what we see as a callus or a corn. All right, now I said some of this already, so my apologies for kind of being on repeat. But here on the PowerPoint, it says the 4 important events that occur in the stratum granulosum are going to be all about the production of our granules, and they are going to release this particular protein called filaggrin. And the name is not that important for us. What's going to be important is that it allows the keratin to form the tough bundles that are needed for it to obviously perform its ultimate function, which is going to be to waterproof the layer. It doesn't do it alone, so the keratin can't do it alone. There will also be things like lipid mixture, little fat that will come from membrane-coated vesicles that will help out and waterproof the stratum granulosum. Once this occurs, because of the cutoff of nutrients, the keratinocytes will get rid of their organelles, so that's why on the illustration we no longer see the nucleus as prominent, and the cell will eventually die off. Now here at the bottom, it just reiterates the fact that your water barrier is actually very beneficial because it's going to allow us to hold on to water retention, so it makes it less likely that we start dehydrating. And also it will go ahead and form a protective layer for any type of pathogen that might want to try to penetrate within our epidermis. All right, so that was our epidermis. So that's the top layer. Please make sure that you take a look at your notes and on your epidermis that you've notated the different cells as well as the different stratums or sublayers that you find within the epithelium layer. And then whenever you're ready, let's go ahead and take a look at the next section of skin. This is going to be the dermis section. The dermis section lies right underneath the epidermis, and it's going to be full of connective tissue. Its thickness can vary depending on what part of the body we're looking at, but it's also very important to point out that the dermis is going to be an excellent way for us to resist stressors and high levels of abrasion because it's going to have lots of collagen fibers that are embedded within it. Now, this makes sense because remember in chapter 5, we discussed the fact that connective tissue, the cells don't tend to make as much contact, but the cells will have lots of matrix background as well as fibers that will help with its overall morphology appearance. The dermis layer, because it's connective tissue, will also have lots of blood vessels. And in addition, you will also find abundant sweat glands, sebaceous glands, and nerve endings. This is where you house your hair follicles and your nail roots. And in case you're wondering, your dermis layer is the layer in your face that will directly connect with our skeletal muscle, allowing for our facial expressions to show. Here at the bottom, it kind of talks to you about what we call a wavy, conspicuous boundary with the superficial epidermis. What does that mean? Well, do me a favor, go ahead and look down on the palms of your hand. And you're going to notice that on your fingers, you have little fingerprints. You have little lines that make a unique pattern. Those lines that you're seeing, as well as if you take your finger and you kind of contract it, so you kind of squeeze it in, see how it makes these little deep marks as your fingers are folded into threes, right? Make a little claw formation. Those little deep folds that you see, those are evidence of the dermis layer peeking out from underneath the epidermis. So your fingerprint, your little dermal papilla, and those little ridges and lines that you see on your fingers, that is nothing but the epidermis allowing the dermis to peek up through. In fact, if you've ever had a blister is when liquid collects between the epidermis and the dermis layer. And then something else I want to point out to you. If you cut yourself and you start bleeding, the reason you're bleeding is because the cut was deep enough that it made it through the epidermis and the dermis. If you only damage the epidermis, the top part, that's when you get a little scratch on your body and you get that little white line, but it doesn't really bleed. And the reason for that is because your epidermis, your top layer, doesn't have any blood vessels. So it will show some damage, but it can't bleed. Whereas if the cut is deep enough that it starts bleeding, that means that you've nicked some of the blood vessels that you find at least in the dermis layer of the skin. Just a little FYI. All right, so here's my picture again, and I added this because I wanted to just highlight the fact that we've now moved on to the dermis, so the second layer of skin, and I wanted to once again, as I was mentioning to you before, highlight the fact that you have lots and lots of blood vessels as well as nerve endings that you find in this layer. Also notice how from its morphology, or I should say its histology, that it doesn't have a lot of cells that are interacting with each other, unlike the epidermis, but instead it has lots of collagen fiber and matrix, which is typical of connective tissue. Now, I do want to point out that the dermis layer itself will be composed of two sublayers. You have the papillary layer and the reticular layer. The papillary layer is the top layer of the dermis. So as you can see right here, it says superficial zone, so it's the top layer. This is the layer that makes contact with the stratum basal. And for the papillary layer, please know that it's mostly composed of areolar tissue. So the specific connective tissue here is going to be your areolar tissue. And obviously, lots of blood vessels. Underneath the papillary layer, you're going to have the layer that's called the reticular layer. This one is going to be deeper and thicker. It's going to be composed of dense, irregular connective tissue. Now recall from chapter 5 that dense irregular tissue meant that it's full of collagen fiber, but it gets its irregular marcation because they're scattered at random, unlike dense regular tissue, which is in a very parallel format. So the papillary layer, the layer on top, is made out of areolar tissue. The reticular layer, the bottom layer, is going to be full of collagen in the dense, irregular connective tissue. And something interesting to point out, stretch marks. So if you have stretch marks anywhere on your body, this is due to the fact that you have tears in the collagen fiber. If there ever is an expansion of the dermis layer, whether abruptly or quickly, so for instance, maybe over the holiday we ate a little bit too much food, so now we've gained a little bit of weight, our belly is a little bit larger than normal, or if someone becomes pregnant, or even if you start working out and the muscles start expanding, what we see happening is that if the dermis layer has to expand rather quickly, it can go ahead and do so, but one of the side effects is that it might accidentally tear open the collagen fibers that it's so rich with. And when the collagen fibers tear open, that are those then the little stretch marks that you see. So those little white lines that you see running through where you have stretch marks, that's nothing but collagen fibers peeking from the dermis through the epidermis. Here's a nice little illustration of the dermis layer. So let's start on A right here. And I just want to point something out. Please keep in mind that this layer right here and this part right here, these two are collectively making up the epidermis. So that's the top layer. This right here is keratinized cells. So these are the dead cells that are flaking off. And here in purple or pink, those are your keratinocytes. So they're doing the journey of starting from stratum basal, the bottom, making their way over to the stratum corneum. In blue right here, and you can see that they've kind of sectioned it off and highlighted it for you. This is then going to be your dermis layer. Notice how the dermis layer is full of connective tissue. So they went ahead and they highlighted the top part, which is the papillary layer made of areolar tissue, whereas the reticular layer at the bottom is going to be full of these beautiful collagen fibers. And that is then what's going to help us make the dense, irregular connective tissue found there. All right, so back to that picture that we keep seeing. So we have discussed our dermis layer. We have discussed our epidermis. Now, as you can see, the dermis layer wasn't as bad, right? All we had to know is the fact that it has connective tissue, lots of blood vessels, nerve endings, and of course the difference between the papillary layer and the reticular layer. So let's go ahead and explore the layer that is not officially part of the skin, but yet we always discuss it in conjunction. It's the layer that lies underneath the dermis. This is going to be called the hypodermis. The hypodermis is a combination of areolar and adipose tissue. It really is just mostly adipose. Lots of fat tissue that lies in here. And that's because it has a padding effect as well as a binding effect of allowing the skin to kind of adhere to its different sublayers. The hypodermis is the site of lots of vaccinations, and that's because it has an abundance of blood vessels there so that the medicine can quickly circulate throughout the rest of the body. Because of its high levels of adipose tissue or subcutaneous fat, we can also see that at the bottom of the slide, it points out that the hypodermis can serve as an energy reservoir, also for thermal isolation, so for keeping the body warm. And from a genetic standpoint, we see that women tend to have a thicker layer of hypodermis. Part of this comes from the ability of carrying a child. Carrying a child is something that requires lots of energy, so your hypodermis can store adipose tissue there for consumption during pregnancy. And of course, in infants as well as in the elderly, this layer does tend to be a little bit thinner. All right, so here is one more picture. This is the picture that started our conversation when we introduced the integumentary system. And I wanted to come back to this just so we can once again point out the fact that starting on top, we have our epidermis made out of epithelium tissue. We have our dermis full of blood vessels made out of connective tissue. And then right here is our hypodermis, the layer that's not officially part of the skin, but we always discuss it either way. And you can see right here from the coloration, lots of yellow to indicate lots and lots of adipose tissue. And once again, just want to highlight also the appearance of the blood vessels in both the hypodermis and the dermis. And as you can see, you can also see some of the accessory, such as the hair follicles and the different glands that have been pictured. I'm going to go ahead and stop part 1 of our lecture right over here, and then we will pick up for part number 2, where we can go ahead and explore the functions of the melanocytes, and we can also discuss a little bit more disease models such as skin cancer, and also the effects of burns on the body. All right, just a gentle reminder, if you have any questions, comments, or concerns, please feel free to email me at any time or stop by the office hours or use your discussion board. Either way, know that I'm available to answer your questions and ease some of your concerns. All right, until next time.